The focus of this video will be on the angles that are formed when tangents, secants, and chords intersect. So before we get started, it's important to understand some basic vocabulary. A tangent is just a line or part of a line that intersects the circle at exactly one point. So for example, in the picture that's shown to the right, a tangent again would be anybody that intersects the circle at exactly one point. So line CD would be a nice example of a tangent. A secant is a line or part of a line that intersects the circle at 2 points. So if I go back to the picture, I feel like there's more than one secant in the picture. But we're just going to say line EB is a secant. Why? Because line EB intersects the circle at 2 points. A chord is a line segment whose endpoints are on the circle. So in this picture, line segment AC would have its endpoints A and C on the circle. And again, that's what makes it a chord. Notice that tangents and secants are both lines, whereas a chord has to have endpoints. It has to be a line segment. All right, so we're going to go ahead and we're going to take a look at what happens when these lines or parts of lines intersect to form some angles. We're going to categorize them in two different ways, one of which his vertex is on the circle. So we know from our previous studies that an inscribed angle is an angle whose sides are chords and whose vertex is on the angle or on the circle. So if I look at the picture, B is the vertex, it's on the circle. Its two sides are made up of chords. Its degree measure is going to be half of the arc that it intercepts, or in other words, half of 100 degrees or 50 degrees. That's review from the previous video. So if you need some refresher with that idea, you want to go back and revisit the video on central and inscribed angles. An angle that's formed by a tangent and a chord will also have its vertex on the circle. So in this case, notice that the vertex of this angle is on the circle, and like the inscribed angle, his degree measure is going to be equal to half of the intercepted arc. It's sometimes difficult to find the intercepted arc. I'm going to show you a trick for that when you come back to class. So half of the intercepted arc would be the arc that's contained in between the sides of the blue angles, or half of 120 degrees, which is 60 degrees. And again, notice that the vertex is on the circle. The angle that's formed by a tangent and a radius, well, here's the tangent, here's the radius. Notice that his degree measure is always 90 degrees. And the reason for that is if I were to take and extend the radius to the other side of the circle, his intercepted arc would be 180 degrees, making his measure also half of that 180 degrees, or 90 degrees. So notice that whenever the vertex is on the circle, the degree measure of the angle is always equal to half of the degree measure of the arc. Let's go ahead and let's take a look at what happens when the vertex is outside of the circle. In the case of the angle that's formed by two tangents, notice that the vertex of the angle is outside the circle. The degree measure of that angle is going to be half the difference of the two arcs. So I almost would say angle is equal to half of the difference of the two arcs. And the two arcs we're going to find first by looking at the major arc, the arc that's greater than 180 degrees, and secondly by looking at the minor arc. And I'll show you a little trick to help find these arcs again when you come back to class. So in other words, the degree measure of angle B is going to be half of the difference between 260 and 120. And if you plug 260, subtract 120 into your calculator, you'll find that the measure of angle B is equal to 40 degrees. Likewise, when two secants intersect, notice that that point of intersection is outside the circle. And when the intersection of the two, whether they're lines or segments, lives outside the circle, the rule says that the degree measure of the angle is always half of the degree measure of the difference of the two angles. So in this case, again, it would be arc AE and arc BD. So the degree measure of angle C would be equal to half of 80 minus 20, or half of 60, making the degree measure of angle C 30 degrees. But again, when the vertex is outside the circle, the degree measure of the angle is equal to half the difference in the degree measures of the arcs. The angle formed when a tangent and a secant intersects, again, I'm noticing that the vertex of the angle is outside the circle. He too is going to follow that same rule where the degree measure of the angle is equal to half of the difference of the degree measures of the arcs. So one of those arcs is going to be that 100-degree arc. The other of those arcs is going to be the 30-degree arc. So the degree measure of angle B is going to be half of the difference between 100 and 30, or half of 70, making the degree measure of angle B, 35 degrees. Let's take a look at what happens when the vertex of the angle is inside the circle, but not at the center. This says that the angle, or the measure of angle BED, and angle BED is represented by X in the picture, is going to be half the sum of arcs AC and BD. And it's helpful to understand why or how come that is. I want you to take a look at angle X. In the picture, angle X has a little vertical buddy. His little buddy is directly opposite him. Each of those angles has an arc that goes along with it. The arc that goes along with angle X is arc BD, and the arc that goes along with the vertical angle for angle X is arc CA. And we can see quite clearly in the picture that those arcs are different sizes. So what this formula does is this formula actually takes an average of those two arcs. So by taking half the sum, we're actually averaging them. So in this picture, the measure of angle X is going to be equal to the sum of the two intersected arcs, 70 and 170, making the value of X 120 degrees. But again, what we're doing is we're saying the degree measure of the angle is equal to half the sum of the two arcs, or the average of the two arcs. And we know from our previous studies that when the vertex is inside the circle and at the center, the degree measure of the angle is equal to the degree measure of the arc. That would be a central angle. So in this case, X would be equal to 80 degrees. In this video, I've given you a lot of different formulas. What's going to be really important is that you memorize these rules, memorize the formulas. It seems like kind of a lot, but when the location of the vertex was at the center, that's review from yesterday. So we said the degree measure of the angle was equal to the degree measure of the arc. When the vertex was on the circle, this is similar to the rule that we learned yesterday with respect to the inscribed angle. The degree measure of the angle is equal to half the degree measure of the intercepted arc. There is an exception to that rule, which we're going to talk about the next time that you come back to class. When the vertex of the angle is inside the circle but not at the center, the degree measure of the angle is going to be half the degree measures of the sums of the intercepted arcs. And when the vertex of the angle is outside the circle, the measure of the angle is equal to half of the difference of the measures of the intercepted arcs. So I think if you focus on memorizing the rules that are in this table, that might make things a little bit more manageable for you. We will, the next time that you come back to class, talk about the exception to the on the circle rule. But in the meantime, I want you to see if you can use the rules in this chart to go ahead and to solve the questions on the next page.